Hi everyone, in this video, I will be sharing some of the exciting new features as part of the DSG 10ep5.3 release. These new features are focused on enhancing the operational geology workflow in DSG software. This video is split into 3 parts. The first part of the video will focus on the new feature of DSG 10ep5.0 for Operation Geology. For those of you upgrading from the DSG 10ep4 series, this first part of the video might be an interest to you. For those that are already in the DSG 10ep5 series, the new feature of DSG 10ep5.2 will be highlighted in the second part of the video. The third part of the video will focus on the latest feature we added as part of DSG 10ep5.3. For those interested in skipping ahead in the video, the timestamps are posted here. As part of DSG 10ep5.0, we include the ability to lock and unlock preferred interpretations in the horizontal well correlation workflow. Via Interpretation Loader, you can now select interpretations that you wish to lock so that other users cannot edit them. This enhances the multi-user's HWC workflow by enabling the user to lock these interpretations, stopping unwanted edits, and ensuring the mapping workflow is kept evergreen with preferred interpretation. By locking down these interpretations, now you have gold standard interpretations that remain untainted by other interpreters' edits. Now let's take a look at new features for DSG 10ep5.2. In this release, we will focus on the 2 new areas that center around the operational geology workflow. Both features operate on the horizontal well correlation license and will be available by upgrade request for those who have existing licenses. First, we have a new dedicated 3D view for well execution called Wellbore View, and the second new functionality is added to the classic horizontal well correlation workflow in the form of a new layers module. Let's dig into more detail for the first feature, the Wellbore View. The Wellbore View is a new view editor in DSG that centers around the drill bit as the well is being executed. The idea here is to provide a dedicated workspace for geoscientists who are operating their wells in real time. Using this new 3D view combined with other view editors like Horizontal Well Correlation Workspace, we can now get a focused look at the drill bit and the surrounding information that can impact drilling decisions. The Wellbore View feature displays a fixed position around the wellbore's bottom hole location that dynamically follow the TD as it is updated, giving users a third-person view of the well. Additionally, visualization enhancements have been added to this view editor, such as the display of notes in 3D, MD labeling, and data filtering around the wellbore. Tools such as a dynamic distance measuring tool, heads-up display, and features related to displaying data based on the TD update time have also been added. The purpose behind the Wellbore View editor is to provide a more accurate digital twin of wells as they are executed and to provide a simple 3D view with limited setups that operations teams can use to co-visualize relevant data and place the executing well in geologic contexts. Let's take a look at some of the visualization enhancements that have been made in this view. First, we have a series of fixed viewpoints available in this view in the top left-hand corner of the toolbar. We have a top-down view, a bottom-up view, and a left and right view. These views control the angle of the camera relative to the TD positioning. So, for example, the default is the top-down view here. We're looking down on this view at a 20 degrees angle at a distance that can be dynamically updated. You can use the scroll wheel in and out, or we have a bar here that updates dynamic zoom. What is great about these fixed views is that as the TD updates and more information is added to the well, the camera will center on that TD node and will refixate on that TD node at the same angle we have set for the fixed view. This leads to increased clarity on the different angles we can have in the scene and helps display your data in context to the surrounding information. Let's now have a look at some of the changes we made to viewing notes in 3 dimensions. There are 2 types of notes in DSG. The first one is called interpretation notes, which float in X, Y, Z space. The other, which is called well notes, which as the name implies, are tied to an individual well at a given measured depth. iNotes are now viewable in the new Wellbore Viewer and in Cube View, with well notes being exclusive to the Wellbore Viewer. We can now display these well notes in 3D and individualize how they are displayed on an individual level. Previously, we had the well note types be the overriding parameter for how we were going to display the well notes. Now we can individualize each well note as a separate entity, orient them with a right or left orientation, and control show or hide individual notes within these note types. We've also introduced some smart logic in 3D to prevent overposting of these notes, so the notes will dynamically change which side of the well they are displayed on for clarity of the display. We can use these well notes to show things that might be a risk when it comes to executing a well, things like microfractures that we may not have picked up on the seismic, or even formation evaluations that indicate where good formations may lie. All this ties back to displaying your risks and understanding those risks in a pre-drill scenario while you are executing your well. Now let's have a look at the visibility filter available in the wellbore view. The idea behind this is to filter your data around your currently executing well, based on relevant information as deemed by the user. So, we have two different parameters we can set for the filter lateral extent here, which are the width and the height of the filter. We can filter several different data types including 3D grids, 2D grids, frameworks, horizons, and faults. Each data type operates independently from each other. This means you can filter out only 3D grids and leave normal display for 2D grids, and this does not impact other advanced visualization displays, things like overlay of the seismic attributes. Using this tool, you can increase the clarity of your data that's around your executing well by filtering out data that you've deemed unnecessary or irrelevant. Now let's turn our focus to some of the tools that I've built in the wellbore viewer. Firstly, we have a dynamic measuring tool that measures the distance from the TD of the well to any object in the surrounding scene. We can make this static in that we can click on an object which will post the distance to that object related to the TD. As the TD updates, this distance will also update, meaning you can always keep track of hazards and surrounding information relative to your drill bit location. Next, let's look at the heads-up display. The heads-up display allows you to display a simple pop-up of information that is useful to communicate between geoscientists and drilling engineers. The idea here is to have a simple pop-up that reads out information such as total measure depth, vertical depth, survey depth from the directional survey as well as inclination and azimuth, and some engineering parameters such as ROP. As with most things in the wellbore view, this is designed to be updated on the fly as you add more information. This means you can always have the latest information at your fingertips to help with that communication between drilling engineers and well execution teams. Lastly, let's have a look at some of the features related to the TD information and how we can use that as a criteria filter on some of the information we're displaying in the wellbore view. There are three main features added related to TD information displayed in wellbore view. One is to color nodes based on activity. This allows you to color the bottom hole symbol based on some cutoffs in terms of TD update time. This stoplight system means you can always know which of your wells have been updated within a certain time constraint. For example, the wells shown in green here in the image have been updated within the last half hour. This means you can get a holistic approach to what your field view level is in terms of activity. This could be applied to much longer timescales. For example, if you wanted to see the wells drilled last year, you could set the time here to be relevant to that time frame. This means you don't have to keep going back and checking the database to figure out when the last update time for your well has been. This means you can get to work faster on analyzing the new information that has come in. Additionally, we've added a TD status bar, meaning if you hover over one of these bottom hole symbols, you can get a call out for the last time the TD was updated. Finally, we've added this feature to give a heartbeat function to wells as they're updated. Sometimes it may be difficult to see when a well is updated, particularly at a far back zoom scale. This allows you to see when the TD is updated by giving a blinking indicator, indicating the TD has been updated and is up to date. Now let's take a look at all these features combined with the wellbore view to show them in action. Here you can see some information that I'm wanting to view in a wellbore view. I have an actual well, which is an executing well showing green, and a well plan that I'm trying to execute upon shown in navy. You can see here I have the fixed view for the well bore viewer set to top down, and I can dynamically zoom in and out to set my zoom level. You'll notice as I update, the zoom remained fixed. When I update the well, you'll notice that the TD node, or the bottom hole symbol, changes colors to green, and you'll notice the blinking indicating the logs and updated. Here you can see various fixed views top down, left, right, and bottom up. These views will remain static, at least the angle will, as the well is updated. Here, I'm modifying the visibility filter, meaning you can filter out and things like 3D grids and framework surfaces in this case. You'll notice that I can also rotate within the scene. It does not have to be fixed, and I'm able to filter at a sublevel, my 3D grid, either based on layer or aerial extent on top of filtering it around my well bore. The heads-up display is now being shown here, and you can see as I update the well, the information will also update on the fly. We can also see the measure distance tool in action here. When I activate that, it snaps to the TD node of my active well and gives me a straight line readout distance to any other data object. Notice that as I update the well, the information will also update, meaning I can use this in congruence with the HUD to provide accurate and updated information to my drilling team. You'll notice some of the TD tools I described earlier on display here. When I hover over the bottom hole symbol on a given well, you can see the TD update time. Additionally, here you can see the color by status shown in a stoplight style, meaning I can get a holistic view of my field and understand which of my wells have been updated within a given time frame. We can go to the bottom hole symbol dialog here to change the cutoffs for how we are displaying these different symbols. The final feature I'm showing here is the various well notes that we can display in the well bore view. You can see that these are updated as I rotate around the scene so that they're not overposting, and they can be displayed in various ways on an individual basis in this well note details dialog box. We can use the well bore view in combination with other well executing views such as a horizontal well correlation workspace to give a 3D view that doesn't need to be modified much to see what is going on. Here, you can see I'm updating my horizontal well correlation look ahead, and in real time I can see my well update in 3 dimensions and get redoffs from my HUD. All of this provides a collaborative workspace and a dedicated workspace for operations geologists to perform their work, giving new insights via a 3D view that provides a better representation of the digital twin. Finally, let's take a look at some changes made to HWC in DSG 10ep5.2. Primarily, we added a new tab within the horizontal well correlation workspace called the Layers tab. This functions on a different algorithm to the traditional surfaces mode, which was limited to just a top-down geometric spacing. The new Layers tab means that you can set up your conformance amongst the different intervals in a similar way you can with the complex geology frameworks. You can have multiple layers in here represented by a top-down, proportional space, or bottom-up conformance, meaning the calculation we're using to calculate a predicted log can vary amongst the different layers. This is powerful in that you can use things like top-up conformance in areas that have a truncating unconformity to get a predicted log, whereas previously you were not able to do so. Additionally, we've added the ability to edit the surfaces themselves via control points on the surface, which updates the predictive log generated. This mode is perfect for generating a workspace, a sandbox-type workspace in which you can adjust the layers based on regional settings that you've deemed appropriate and see the impacts on a predicted log. The structure can be updated either for an individual surface or the whole framework. Control points can be added to choose a static point that will not change as you update the surfaces. Additionally, faults can be added, and throws can be adjusted to update your section. These new enhancements mean that you can do your pre-drill prognosis in a complex geologic setting and adjust the predicted log accordingly, allowing for more accurate representation and better analysis. Let's take a look at these features in more depth. In this field, you can see a complex geology setting with an unconformity coming through and truncating certain surfaces and some faults affecting the structure of the region. Using an offset well, you can now generate a synthetic log using complex geology rules and scenarios, allowing you to understand your reservoir and tweak your regional structure before drilling begins. The new editing mode, under the Horizontal Well Correlation Layers tab, enhances the understanding of the subsurface by utilizing dynamic framework to fill to construct a predicted log that accurately represents the structural model. In addition, this tool provides unique geologic layering rules that can be easily utilized to construct the predicting log curve that represents the subsurface current understanding. Here we can add surface control points and flex the surfaces to impact how the predicted log is calculated. We already established our layering information. We can add more things such as faults or dip adjustments to the actual surfaces themselves. Using this adjustment, we can generate a new predicted log and determine subseismic information such as faults that are not picked up from the seismic section or regional adjustment to the dip. Once the pre-drill evaluation has been completed, horizontal well correlation helps you understand real-time stratigraphic positioning through the correlation of the synthetic log and real-time log. Let's move on to the latest features I added for DSG 10ep5.3. In this release, we will focus on the two new areas that center around the operational geology workflow. The first feature is an additional functionality for well bore view. This feature operates on the horizontal well correlation license and will be available by upgrade request for those who have existing licenses. The second new feature is a new feature called synthetic image log. This feature creates pre-drill structural analysis along the borehole. This feature will operate on the DS Geology interpretation license. Let's start with the first feature. Wellbore View Alert Notification is an automatic notification system that will be triggered if the total depth of the well you currently monitored is within a certain proximity range of well notes. When the TD of the wellbore exceeds the proximity radius set, the alert notification will be triggered, and you will see a pop-up dialog showing the distance of your drill bit to the well notes, and descriptions of the well notes. Having the well notes interpreted around the wellbore and an automatic alert system will help operation geology to track the position of the bit. Using this feature, operation geologists and drilling engineers will be informed of subsurface conditions ahead of the drill bit. With detailed instructions and descriptions of well notes, it can improve the communication between operation and subsurface analysis to overcome the operation hazards. Here in DSG session, I have a well plan in red and my actual drilling well in green. I also posted interpreted well notes along my well plan trajectory. When the position of my actual well is updated, and it is crossing the alert radius set from well notes, then the alert notification system will be triggered. It will display a pop-up dialog called Well Note Alert. The Well Note Alert dialog will show the information on the distance between your actual well TD to the position of the well notes. It also shows the description of the well notes. On the Well Alert notification dialog, you can see the Alert Summary option at the bottom of the dialog. Alert Summary contains the information of all the well notes that have been tagged as alert. Another option is called Well Note Details. In this dialog, you can pick and choose which well notes will be tagged as alerts to trigger the automatic alert notification. Moving on to the second feature. In the DSG 10ep5.3 series, you can create synthetic sinusoids from the intersection between the well and the framework. From these intersections, the algorithm will compute structural components to draw sinusoid lines such as apparent dip angle, true dip angle, and true dip direction. The result of this intersection is plotted as a sinusoid line on a normal well correlation view or in an HWC horizontal correlation view. What is great about this feature is that allows you to analyze the structure before well execution, and because this feature uses a framework as a reference, then the synthetic sinusoids will dynamically update if the reference framework is updated. This will give you advantages during operation to understand the position of the drill bit relative to the structure. Also, during operation, these synthetic sinusoids can be compared with image logs from MWDLWD and will improve your analysis and support faster geosteering decisions. If during operation you notice that the observation of the formation top is deeper or shallower, you can always incorporate this new formation top observation into the framework and the synthetic sinusoids will be updated during drilling. Let's see the workflow to create synthetic sinusoids. In the DSG session, I already prepared a framework that contains multiple surfaces. The blue well you are seeing on the screen is my well plan that I saved as an OpenWorks well, and I include this well on the framework building. From the well cross-section, I can see that my well plan is intersecting with multiple framework surfaces. Using the predicted tops feature, in well correlation I can display these intersections as predicted tops. Let's now focus on the well correlation view. Predicted tops from the framework intersections, as here displayed by the dashed lines, are representing the intersection points between the wellbore and the framework. In the background, the algorithm will extract and compute the structural properties such as true dip, apparent dip, and dip direction, and then draw a sinusoid line, we called it synthetic sinusoid, from those values. The computed synthetic sinusoids will be automatically displayed at the log track where you clicked it. And you can also notice there is synthetic sinusoid header appearing on the log track header. Because of the vertical scaling, the synthetic sinusoid lines might appear as flat lines, so you might need to zoom in to see the curvature or shape of the sinusoids. When you hover your mouse pointer at a sinusoid line, the cursor tooltips will give you information about the reference framework used, the framework surface intersected, true dip, apparent dip, and dip direction. Additionally, we added the feature of the properties of the borehole and sinusoids drawing reference. Using the borehole properties dialog, you can set the value of wellbore diameter, depth of investigation, and sinusoids drawing reference to ensure that you are using valid wellbore diameter to draw synthetic sinusoids. Now let's take a look at the synthetic sinusoids feature that can be utilized for optimizing operation workflow. Once the image log data is available, you can directly QC your pre-drill analysis with image log data. This red dashed line is the prediction of the top reservoir from the framework. Comparing it with the image log response, we can see the position of the top reservoir is quite a good match with the resistivity log response. Using the synthetic sinusoids feature, I can display the structural properties of the top reservoir and compare it with the image log data. As you can see in the result, the shape is a good match. However, my pre-drill top reservoir prediction was missed by a few meters. Using the guidance of image log data, I can fix the position of top reservoir picks. Using the well pick interpretation tool in DSG, I can adjust the depth of the top reservoir picks to match with the image log. Another thing I can do is add the information on dip angle and dip direction for the picks. Because the shape of the structure is a relatively good match between my synthetic sinusoids and the image log response, I can use the dip angle and dip direction from the synthetic sinusoids and input them here. Now as you can see, I have the high confidence structural framework that both QC'd and matched with my image log data. Combining image log analysis and synthetic sinusoid workflow resulting a powerful during drilling structural adjustment workflow that can lead to optimizing well position on the zone of interest. Thank you very much for your attention. For additional questions and comments, please contact your local landmark account representation or landmark support.